Okay, guys, time to start. So the next session that we've got, it's about extracting credentials from the disk, where we can find them, what are the ways to do it, what are the eventually permissions needed in order to get access to them, and so on. A couple of words about myself. You have already seen the keynote, but if you have joined us very shortly, my name is Paula J. I get a pretty complex surname because it comes from Poland. I spend a lot of my days in travel, being among different locations. And basically what I do every day is penetration testing. My job is to get access to the customer networks. I'm not the only one. There is a team with me. I have established a company in 2007, and right now there's 13 of us. A bunch of little geeks trying to play with security in a couple of interesting ways. Anyway, if you are here after the keynote and you saw the keynote, and I of course see faces that I saw in the keynote too, if you're wondering about the demo, because one of my demos didn't work out, the restart was necessary. Yes, I really hate to say this, so I'll be showing you the whole path amongst the network attacks at the end of the keynote, because this is actually something really serious to get into, and it's going to be very smooth, you will see. Anyway, for today, we've got the passwords being on the disk. So all the interesting places that we've got where the password is on. Before we move on, a couple of words to mention. If you will be interested within the conference to fill up some geeky security quiz, no like registration required or anything and so on, just fun, go ahead, because I have created 25 questions. They're quite difficult, so don't be discouraged, just feel challenged, and I'm really happy to see within the day what is your score. If you score lower than 13, then 13 is an average, so putting this way, but if you score anything higher, I'm super happy to see, because it's already a good score, okay? So this is a little bit of a thing. Feel challenged, absolutely feel challenged. Anyway, let's talk about credentials. First of all, whenever we think about the credentials being written on the disk, this is a little bit of a challenging thing, because there are so many ways how we're able to proceed with this. And whenever we are thinking about credential types, what kind of credentials do we have, where they are stored, and so on, there are plenty of places we should have a look at. One of them, it's obviously something that we all know, which is the SAM database, or ntds.dit within the Active Directory domain controller, where we store MD4s, so MD4 hashes, of the user's passwords. Now, that hashes are encrypted. So hash, of course, cannot be decrypted, but the hash value itself, it's encrypted. And long story short, they are finally encrypted with something that we call a boot key. And boot key is something that you find within the registry in the system hive. Seriously, if you've got a boot key, you've got a growl, because boot key is allowing us to access a bunch of things. One of the things that it allows us for is, for example, to access the computer account password. So the computer itself has a password, somehow it needs to authenticate to the domain, right? But that password is exactly the same as the local system password. Or we could say local system's account password is the same as the computer account password. So in order to be able to get access to it, we need to have an access to the system hive in order to get access to the boot key. Now, question is, how boot key is encrypted? Well, answer is, it's not really, because if we are rebooting our system, somehow operating system needs to read some database. We are not the ones decrypting it. It needs to be decrypted by getting access to something that everybody has access to, which is, of course, system hive. This is the principle for understanding credentials and the places where in operating system credentials can be and if they are safe or not. To be sincere, I love this slide because it really presents all the interesting approaches we can take to get access to credentials. So some we know. Second thing, whenever a security of the passwords of the different security mechanism relies on the boot key, and it does, it's not very secure as long as we've gotten access to the boot key. And boot key, it's kind of funny, because it consists of, it's built upon the different types of class names that we've got within the registry hives that you've got on the slide, yes? So as long as we get access to it, we are all set. Now, LSA Secrets is a cool thing, because LSA Secrets, so the passwords of the service accounts that are stored within the registry, they all rely on the LSA, so Local Security Authority, so effectively local system account secrets. So local system account, we all know what's that, yes, basically a bunch of services are running on it. This is a built-in system account, very special, and in order to get access to the password of this guy, and again, as we already mentioned, it's in the registry, we are able to decrypt it. So if the secrets or LSA secrets rely on the Local Security Authority subsystem's password, we've got access to secrets, yes? So this is a little bit of a logic there. At the end, it's actually quite simple. The most difficult ones over here, it's something that we call cache credentials or cache logons. Actually, I like to call it cache logon data, because this is something that relies on an MSDCC2. This is an MSDCC2 value, and it relies on the PBKDF2 function. I will be talking about this in a moment, because, and I'm not bullying around, that's actually true, we are the only team in this world that reverse engineer them, so if there is someone that can tell you 100% how it works, it's really me. Yes? It sounds horrible, but it's the truth. So let me move on. At the very beginning, a little bit of a lightweight presentation before we get into hardcore, which is technically my favorite part here. Okay, so let's dig in. Intro, we've got data chunks, system scenarios, and summary. Whenever we think about different types of places where the passwords can be in, yes, it's not only the SAM database and so on, but it can be also different cache. So if user left, for example, some file somewhere, and it was a small file, and then it got deleted, we can still, for example, recover it from the disk, yes? Especially if it was less than 1 kilobyte, yes? So this is something that we can spot here. All the interesting places like Hyperfill file. We're gonna start from this one. Hyperfill, so hibernation file. I'm such a person that is against hibernation, and hibernation only makes kind of a sense when we've got the disk being encrypted. That's the only situation where it's okay. Yes? In the rest of the situations, it's absolutely not. And of course, demo is coming. So hyperfill.sys, it's placed on the drive, on the root of the drive, and it contains what we had in the memory. And this is an image that we're going to have loaded to the memory after we power on our computer. And whenever we think about what the hibernation file contains, well, obviously it contains all the stuff that was in the memory before. So I was kind of showing this a little bit in the previous presentation, but I want to show you this from a different perspective. So what do we have over here? I got here 2 hibernation files. Yeah, one is for Windows 7, another one is for Windows 8.1. It doesn't really matter at the end. And they were all converted from hyperfill.sys. If you're wondering how did I convert them, there is actually, I'll be back to this, there's actually a tool that I'm such a huge fan of this. This tool, it's called, this is this one, Hyper to bin eventually, or dump it. Yes, or Harbor to DMP. There are plenty of them, yes? So these are the ones that we can use to convert hibernation files to some memory image. This is a tool written by Matthew Sish, very nice guy. And right now this tool is available for free, by the way, because it was you had to pay for it. He made it free right now. So this is the way how we are able to convert it, just to tell you so that you've got a background. Okay, now, what we're gonna do, when I got my images, I'm gonna, let's say, take this image, right-click, and I'm going to open this in a debugger. So why in a debugger? Well, because we are playing with the memory dump. We kind of need to do a little bit of more effort here in order to get access to our stuff. Yes. So what's the case? Well, first of all, I will change a little bit of a font so that we are able to clearly see everything that is happening out there. I think that this is good enough. Yes. If you don't see that, you must be really blind, because this is like a big font. Okay, anyway, so the first thing that we see over here is that this is the 32-bit interpretation. Yeah? So this was a 64-bit memory image. Unfortunately, when you're going to be dealing with this, it's always like that. So there is one thing that we kind of need to learn by heart in the debugging tools for Windows, that we need to switch into effective machine, AMD 64, not 65, 64, and right now we're going to be interpreting and moving along the processes that are running within a 64-bit memory space. Now, because this is a full image of the operating system, we need to switch into the process. Yes? So basically, we need to find first !process. And we need to get into lsa.ss.exe because this is a guy that has access to all of the secrets. If we want to talk to him, we need to be in him. So this is the one. And right now, I will do 0 in order to, or actually, we're going to do it like this. Sorry. We're going to do 0 because I don't know the process identifier of that process. And we're going to do 0 because I would like to have a basic information about it. Not like a lot of details about the process itself, but I just want to know where this process is in the memory. So simple thing, yes? So this gives us a 64-bit address within the memory, which I can go to. So in order to go to this, we need to do .process. And then I will just reload the symbols just to make sure that I'm on the fresh page over here. I always want to have the freshest symbols. Now, a little bit of an explanation, what are the symbols? Symbols, it's a direct translation of what's happening within the operating system, so different types of functions and what's happening within them, into what the human being can understand. So normally when we will have a notation for functions 0x something something, yeah, we can learn this by heart, good luck on that, or we can learn by names. So if we are analyzing, debugging software, then we always need to have symbols because it will be not possible absolutely to operate within the numbers. Yeah? So it's like a little bit of dictionary that translates numbers to names. Yes. Okay, so we've got that. This it means that symbols are refreshed. I'm inside the process already. If I do .load, mimilib, this is the way how we are able to load DLLs in a debugger. Yeah, so I'm loading right now this DLL that always comes with a Mimikatz, and you are able to use it within the debugger. Very useful for analysis of the big portions of files, because if you want to analyze, for example, in a Mimikatz hibernation file or just a full memory dump, executable itself it's not capable, that much. It depends on the situation to process all of the things that you know. Debugger, it's much more robust if it's about playing with the big files. So now the only thing that we need to do is ! Mimikatz, and of course what we got on the top, it's the credentials that are coming from the hibernation file. That's my point. So where are they on the disk? They are on the disk, for example, in the hibernation file. Should we use hibernation? It's okay to use hibernation, but only if your disk is encrypted so that someone is not able to pull out that hibernation file offline. You got a question? Oof, you mentioned something cool. I don't know what should I answer to you because it's an answer for like half an hour. But okay, question was, what about disabling cache credentials? Yes, we're going to talk about this, by the way, but it's a very cool subject. Let me keep your question for the presentation because it will be answered within the presentation. But to quickly answer your question, what about cache credentials and so on? Will it help with disabling them? And so on, answer is no. It will absolutely not affect that situation, yes? Okay, let's move forward. I'm happy that you asked this question. I really am, because it's a cool subject. Okay, so let's dig in further. What about hashes? Yes, what about different other places like SAM or ntds.did? Well, and again, let me go back to the previous slide. What about SAM? Well, SAM, this is this green field here. It is to be accessed, yes, whenever we've got it within the registry, so in config. And SAM is actually pretty interesting because SAM itself is a database, and it relies on what other registry have? On system, because it relies on a boot key. So what do we need to get access to in order to decrypt hashes in SAM? To get hashes, yes? Then we need to get access to the system hive. So that is quite interesting too. And let me show you how to do that. So in order to be able to grab the hashes, yes, there are a couple of ways we can play with that. One of the ways, and this is, to be sincere, my favorite way to do it, is that it is actually to launch and play with our tool. We've got over 200 different tools that our team wrote, basically, for different types of hacking purposes. And one of them, and that I'm going to use right now, this tool is called CQ Secrets Dumper. And CQ Secrets Dumper, it's the one that allows us, of course, to extract different types of hashes. And let me show you how it works. And of course, I'm happy to share it as always, yes? Okay, here we go. Secrets dumper is one thing, hash dump is another thing. Okay, so let's dig in. Pong, 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 machine is coming out, yes. It doesn't really matter on which operating system you're gonna use it. Since I'm the picky one in the company, I said to our developer that it needs to be working on every version of Windows ever. And why this is important is because in the past versions of Windows, the access to the different kinds of secrets within the registry, they were relying on the different algorithms. So that's why it's important to have the common tool. Okay, anyway, CQ tools. So we've got these tools, and I'm going to first of all run psexec with the options sid, cmd.exe in order to elevate to local system. There is no magic, by the way. You always have to do it, not because of the system hive in the registry, but because of the sum. System can be accessed by administrator, but sum can be only accessed by the local system. That's the reason. Yeah, so there is no magic. That's what I'm saying. So you have to be a system, or you have to be offline. That's another way to do it, which I will show you within this presentation too. So let's begin. Let's get into tools that we got. And I got here CQ hashdump version 2. CQ hashdump version 2 goes with an option sum dump. And when I do that, what I've got access to, it's, of course, the list of the hashes, yes? And I'm able to take them later, and that's what we're going to be talking at the end of the day, and I'm able to perform, for example, yes, pass the hash attack, or at least impersonate in one of these people that we got over here, yes, which we can do within the pass the hash. We are able to create a token of a user by possessing just a username and the hash. That's a current problem with Windows. Does Windows 10 fix it? Well, this was also your question within the keynote. Yes, but the requirements are big. But if you follow the requirements, awesome, and that is exactly the goal for the implementation of the new technology. So credential guard that we are talking about can fix it, but not on the local account level. That's a problem. So technically, if I take this hash, can I still authenticate it when I have all the perfect set of Windows 10 features implemented? Yes, I can still authenticate with it. That's a problem. Okay, so this is how we are grabbing them. Now, interesting story. What about hashes in AD? Is it the same or is it different? Because in AD we use ntds.dit. And that is an absolute different type of a database. It's a different database. So are we able still, within the domain controller, to get access to the user's hashes? Of course, of course. This is, by the way, a good way to check if someone is reusing passwords within the enterprise. Do we have to, for that purpose, do we have to be an administrator? Well, basically, you have to copy ntds.dit, and you have to copy system. So in this particular case, you need to be an administrator, but you don't have to be a local system. This is quite interesting here. Let me show you how to do that. So what we're going to do for us, I will, well, first of all, grab access to the system hive and also to ntds.dit file. And you can do this by using many ways. In this case, I will use the shadow copies, yes? So this is the setup. Okay, let's dig in. First of all, here is the setup. I will need to get access into my ESEDB, yes, for the files. Here we go, ESEDB, because we've got the format of the database ntds.dit, which is of the ESEDB. So I need to have a tool that will be able to extract from ntds.dit information about, hey, user, you've got these tables over there. Well, what you're going to do with this, it's your problem, but at least I give you the tables. And I'm going to use these tables later, like in SQL Server, the same story, to combine data all together and then extract the hashes. Yes? Still the same things are needed, but it's a different way we use to write the data up. So this is a very straightforward operation. Okay, let's do it. VSS admin. VSS admin. list shadows. Here we go. And not the list shadows, but create shadow. Create shadow. And it's going to be for C, and that's the one. OK, perfect. So we've got this body. Nice, nice, nice. Yes. And we can, simply speaking, copy from that all the stuff that we are talking about. So we are able to copy here Windows System 32, and then it's going to be config, and then it's going to be, for example, some. If we want to copy, copy system, you can do it. You can copy security too. Of course, even though security is only accessible by the local system, just because of the shadow copy. And we can also copy Windows, very important, the most important in this demo, ntds.dit. And of course, I got them all. Now, start dot, let me take it. And I'm going to take these bodies, and I'm going to copy them in a moment into my analysis file. But before we do it, copying them from shadow copy doesn't really change much. I still need to do ESDB export into ntds.dit, and this is the guy that puts me all the tables out. The database itself, it's not encrypted, yes? Database, if you put it in Notepad, you can still read some data in a clear text, but not the hashes, because hashes are encrypted. Yes, so basically, in order to get access to them, I still need to get access to the system hive, yes? So start dot, one more time, and I got this folder over here. So I'm going to take this and take this, Control C, and I'm going to move them into my folder, which is this ntdsx, yes, and I'm going to paste these data over there. I will just replace it. If I've got something over there, then I will just replace it. Here we go, and then let's move back to the folder, ntdsx cls. Let's start the adventure. Now, Python. That doesn't sound very encouraging, I can imagine. Well, depends who likes what. But if you want to have Python running on Windows, you need to have it in 32 bits. And I would recommend version 2.7 because it's the most compatible version with all this hacking cool stuff that is to be found out there. If you're going to have like the 64-bit and the newest, forget it, because it's all social. Like, who really has time to keep up to date everybody else's tools? Yes, nobody does. But 2.7, it's kind of good enough to be compatible with. Anyway, Python, and I'm going to use ds hashes. This is the script that is written by my colleague from Hungary, a very cool guy that does Active Directory forensics. And this is very simple, what we're going to do. We're just going to put over here export, so the folder that we have created with the database, and I need the data table, and I need to combine it with the link table. Yes, so these are the two tables that contain encrypted data that is for me necessary to get access to the hashes and to put the hashes out. Now, password. Let me do this. Password hashes. Yes, and then system hive. Yes, that's the one that we need. And after a little bit of an extract, I hope everything will be okay. We will be able to get access to everybody's hashes. Now, how long does it take for the couple of thousands of users? Yes, within the enterprise, if you want to do it, then it's going to be about 10, 15 minutes, maybe a little bit more. Depends on your CPU time, really, and the CPU, how strong is that. But long story short, at the end, what we've got are different types of hashes, which we can use, by the way, and we can import them in an Excel spreadsheet and see what kind of people in this company are reusing passwords. We could be like, this is not ethical. It's 100% ethical, because you are not reading someone's passwords, right? You are just like, oh, well, apparently, over here, administrator, let's see, oh yeah, I can tell. Administrator, so E19, and Freddy Krueger also, they are reusing the same password. Maybe this is the same person, yes? This is what I selected, underscore. This is something what we call NT-hash. Some people call it NTLM hash. If you can calculate it in your memory, the E19 stands for password P at SSWZRT. It's a joke, by the way. Yes, I'm sure you can't. Yes, I cannot too. Yes, but who cannot calculate MD4 in a memory? That would be cool. I will marry this guy, probably. Anyway, let's move forward. So this is the way how we are able to get access to that kind of data, yes? What else? NSA Secrets, right? So values that are encrypted in a registry, protected by local security authority subsystems data, so effectively local system's password. Local system can encrypt them, so when we have an access to the local system password, we have got access to the local system's profile, and this is the data that we are able to use to decrypt values in a registry. It doesn't really matter what kind of cryptography is used, symmetric, asymmetric, who cares, if we got access to the local systems guy password. That's why we call them NSA secrets. The problem is that if something relies on the boot key and on the machine security, so the password of the local system is in a registry, we cannot think that this is secure. Under any circumstances, online, offline too. If I'm logged on, we could be like, oh, there is a bigger probability to get access to the passwords. No, offline is the same story. Hashes are accessible offline, NSA secrets are accessible offline. All the stuff we are talking about is actually accessible offline, unless we talk about data protection API, which is not mentioned by me yet. It's the first time I mentioned this, yes? So let's have a look, yeah? So NSA secrets, what's the problem with them? Well, the problem is that because they are in the registry, that's the problem. So is there a way we are able to get access to those guys? Absolutely yes. And in order to do that, we need to get access, of course, at that particular stage to Security Hive, which in this case also requires us to be at least administrator with the possibility to impersonate to the local system, yes? We could be thinking, this is not cool. Well, not really, that's how it works, yes? So taking into consideration how we are able to get access to different credentials in the disk, very often we need to be privileged, yes? One more thing I will show you in a moment where user has access to a bit more than it should. Anyway, so this is system. Yeah, so psexec, I don't want to repeat myself. So we are running this console as a privileged user here. Now, if we have a look into the services over here, well, this is kind of logical at the same time. If we've got here, one more thing. If we've got here services that are configured like this, yes. This is GMSA. It's a direct solution of what I will be talking about in a moment. This is regular account. This is a problem, by the way. There is not a single company in this world that was like perfect not having this. There's always something, some service with some account running, and most oftenly, this account is privileged. I'm not saying domain admin because this is already like way too much, but I'm talking about local admin, for example. Yes, so we've got a SQL server running on the dedicated account, which is a domain user, but that domain user is a local admin on the computer. It's absolutely not necessary. The reason why you need to be a local admin is only when you need privileges that cannot be assigned to the user, yes, that the user doesn't have. For example, debug privilege. For that, you need to be local admin. Does SQL Server need to have a debug privilege when it's running? No. Yeah, so why do we give it to him? So this is one of the interesting facts to have a look at. Now, let me show you how it works. First of all, regedit. Let's dig into this. By the way, these are the cached credentials, which we'll be back in a second too. But if we go to, in this case, we can go to, we can go to security, and then we can go to policy. Just to verify and show you why do I need to be a local system. Well, if you have a look over here, local system is the guy that has a full control. But if we have a look over here, it is actually an administrator that doesn't have access to. Can I take over that? Sure, you always can do that. Of course, yes. That's my point. You always at least need to be a local admin. Now, here comes the thing. There is my favorite folder. It's kind of funny, by the way, by the name. I mean, seriously, they could try harder, but no. It's called secrets, yes. Like, do not press this big red button. Yes, of course, we will not go there, yes. So let's get into secrets. So what do we have over here is two things. First of all, it's a service, SC Secure Hacks, and that's the one to which we keep the secrets for. And what is cool is this, machine ACC, and data protection API system. This is nothing but these keys depend a little bit on each other. The computer account password, which I was already mentioning, that is exactly the same as the local system's password. It's over there. Yes, it's over there. And that value is decrypted by having access to the system hive. So where's the problem, yes? So what is interesting for me for now is actually this registry hive. And over here, I've got the current value. And I've got here the Freddy Krueger's password. Well, it doesn't look like a Freddy Krueger's password, unless it is actually the password, but it isn't. So question is, can we decrypt it? Yes, sure, we can. But we can decrypt it by only having an access to the system hive and security hive. Yes, that's the condition. Can we do it offline? Absolutely. You can, because everything relies on the system, as I was already mentioning. I'm repeating myself, but it's important to understand that dependency. Okay, guys, so let's get into the stuff. What I have over here is CQ Secrets Dumper. This is another tool that we wrote. CQ Secrets Dumper, it takes us, well, I can specify here service, secure hacks, and of course it gives me password as a clear text because password is stored in a decryptable form. There is only one place, really, or two places, SAM or ntds.dit, so depends on the perspective and on the machine, where the passwords are stored as hashes. In any other places, they are stored in a decryptable form, depending on something, local system or user, in a case of data protection API. Yeah? So this is a little bit of a case. Okay, guys, now, question is, what else? What else and where else do we have access to? What about things like KeePass? Because this is kind of cool. Yes? Is KeePass safe? Yeah, me too. I hope too. You probably wouldn't be here, and I wouldn't be here if it was all good, right? So let's have a look at what can we get access to when playing with KeePass, right? Okay, so that's going to be a little bit of a demonstration here. And the conclusion is not that bad, but it's also not very good too, okay? So let's get into this. Basically, I got here, well, first of all, I'm logged on over here as an administrator guy. But, wait, I will do it like this. Who am I? Yes, that's better. Administrator. We could be like, meh. No. Data protection API, the classic one especially, it's a very important mechanism. We're going to get into details within the next session, but here comes a little flavor. Data protection API relies on two things, yes? Or security of our secrets, KeePass database is one of them, relies on two things. One thing is my password, yes, which technically I can provide to KeePass, which is the master key password, which is okay. But KeePass can also rely, and you can configure KeePass like this, on your account, on your own local account, when you set it up. Yeah? So protected by the Windows account, it's called. This is one of the options. What is better, I can tell you right now. Obviously master password that you keep here. Yes, you don't rely on anything. You just rely on your own memory. That's it, which is, let's say, okay. What if we choose the other option? Yes. What if, for example, user chooses to protect his KeePass database with the Windows account? Is it good or bad? Depends on your domain admin, I would say. Yes. So if, for example, we do this, we rely from now on two things. One is your password, so the password that you are actually using to log on to Windows. That's kind of good, yes, because if someone gets your password, that's the momentum where you are in danger, but in any other case, you're not. So that's not bad. Hyperfield, remember, this needs to be encrypted. If it's not and you got a hibernation on, then someone has access to your KeePass database finally, yes? But second thing, it's also very cool, because within the data protection API, users, putting it in a short language, encryption keys, they are called master keys. They are also encrypted with the very cool, dodgy, found by us certificate running and floating in the domain controller's memory. So if someone has access to the domain controller's data, this guy or girl is able to get access to everybody's secrets within the enterprise. that's a kind of a not cool thing. It absolutely changes a scope of who is a domain admin or who is not. Do we trust our domain admin? Yes, hopefully you do. But if you kind of don't, that is one of the reasons to implement something that will actually control your domain admin, because this guy, it's so powerful, sometimes even more than we really think. That's going to be our last session, yes, for today. So, long story short, what's my point over here? Let's have a look. First of all, am I able to get access to the user's database? Well, let's see. Users database, so we've got over here, let's get into the users. Let's go into Freddy, and let's get into desktop. This is the user's base, yeah? So I got over here CQ base. And when I try to get access to it, yes, then basically what it asks me to provide, let me just close down things. What it asks me to provide at that stage, it's the master password or the Windows user account. Well, it's not my database, it's Freddy's. So either I provide master password or I try to get access by the user account and I can't. Yeah? Okay, now where's the gig? The gig is when we try to get access to the user's master key. And I got over here in analysis folder that master key being already decrypted. Now, question is, what is this master key for and where does it come from and who can decrypt it? This master key can be decrypted by someone who knows Freddy Krueger's password or Freddy Krueger's hash or someone who has access to the domain controller. Yes? So these are the three conditions, which we can imagine that for the home users, it's not the problem. And it's okay. For home users, it's okay. For the domain users, though, it's kind of like on the edge of violation for the privacy. So let me take this, Control-A, Control-C. And, well, actually, I'm going to take this. And what we're going to do, we will try to get access to this particular database. So let me take this. I'm going to do this, Control-C. Oh, this is the one. In analysis, I got this user's database already. In the user's profile, yes, there is an information about the key that is encrypted, and that's the key that is used to decrypt the KeyPass database. It is within the user's profile, yes? So we need to get this as well. But who cares if this key is encrypted? So how can I decrypt the key that decrypts the database? That's my point. So this is where the data protection API comes to place. So I got all this data needed. So I got the user's database. I got the particular master key decrypted, and I got the encryption key, which you can easily get from the user's profile. Now it's time to have fun, yes? So let's get into this. And I got here a bunch of tools. One of the tools, it's the, data protection API blob decryptor. That's the one thing. A second, KeyPass a DB decryptor. And these are the tools that I'll be technically using over here, yes? So we provide over here the blob, yes, that we've got, and the master, and the entropy. Entropy is actually quite interesting because that entropy, particularly used within the KeyPass, needs to be read from somewhere, yes? And that entropy is actually constant. We are able to read it. So I'm going to read this. This is a random but not random value added on the top of the encryption that makes the hacking a little bit more difficult. So in order to do that, first let me run another tool, which is KeyPass DB decryptor. And this is the place where I've got that entropy given. Yeah, that's the one. Let me take this. And I'm going to use this within the previous command, okay? So let me clear the screen. I got it in my clipboard. And CQ data protection API blob decryptor takes the following parameter: master, entropy, and blob. Very simple. So let's do it. Right now, we're going to do entropy. It doesn't have to be in the order, yeah? So entropy, I got it. Master, I have it in my text file, so I can take this. So I would just get in over there. Yes, this is my master key, Control-A, Control-C. Yes, and then we've got our master. And then the last one is blob. And the blob will be the place where we've got our C analysis. And this is where we give our, not this one, this one. Yes, protect user key bin. Yes, and at the end, this value here, this value that we got over here, very cool, is actually the value that we can use in order to decrypt the KeePass database. So we have decrypted the user's blob. Now we just have to use this against our database, yes? And because, why is such a long thing? Because that database was protected by using data protection API, so the user's passwords. So let's take this thingy, and the next thing will be CQ KeePass decryptor. Maybe let me clear the screen so that we've got it all nice. So CQ KeePass decryptor, we got it, and this takes two parameters, key and the file. Yes? So punc, we got it. We can specify -k, and then we specify the key, and -f, so for the file, or /file, whatever works, C, analysis, and this is the place where we specify the user's KeePass. Awesome. So we have saved an encrypted database into the folder that we were using for analysis. This is a new one created by now, punc. So I try to open it, and now what happens? Well, I can tell you, because we are giving on the top of it the master key password. Which one? CQURE. Let me show you. This is the one. We're giving it within the tool. And question is, can someone get access to the user's KeePass database? Yes. Yes, as you can see. But by having access to the data protection APIs, users' data. Yes? So what is the conclusion coming out of that? Putting this in a humanic language? Well, basically, we should rather not rely the KeePass database security on our Windows account if we are a domain user. That's the conclusion coming out of that. Yes, if you want to be on a safe side. So this is the setup. Yes. So when we are, for example, saving somewhere a database, yeah, that's the point. What I'm talking is this. Yes, this is what I'm talking about over here. So we've got a master password or Windows user account. Use this, not this. Okay? Within the domain. When you are running on the local machine that is not domain joined, it's okay, because master keys within the data protection API, I was saying that someone needs to have user's password, yes, but when the machine is not connected to the domain, the data protection API works a little bit differently. Your master keys are encrypted with SHA-1, and what you extract, as we already know, offline from the database is MD4. So how am I able to convert in between them? Well, I have to crack the password, yes, to be able to calculate SHA-1, to be able to decrypt master keys. But at the moment when you connect to the machine, your master keys are all encrypted with your MD4s. Okay? MD4s cannot be grabbed locally, even though we've got cached logon data. Yes, this is the setup, and effectively we can consider that when we're going to use master password, we will be on a safe page because it's here. And the Windows user account relies on something that domain admin can easily get access to because of an issue in the domain controller that I will be talking about at the end of the day. Yeah, so make sure you stay tuned, get a lot of coffee, because last session will be hard. Yes? Okay. Is there something else we can play with? Sure. I'm pretty sure you are using... Let's move on. I'm sure you are using the remote desktop manager tool. I mean, every administrator has this remote desktop manager tool on board because it allows you to use central sessions so that you are able to connect to the different kinds of boxes out there. Well, it's good. It's saving credentials safe in the remote desktop manager. It's okay. Yeah, okay in an American way means meh. In the European way, yes? So what it means is that it also relies on your data protection API. So what I have over here, it's basically a remote desktop manager. So I will be actually showing you, because Freddy, our user, is an administrator. He has remote desktop manager passwords to different machines saved. Good. Can we decrypt it? Absolutely. As you see, I've got here file and master. So the same story, as long as we've got someone's master key, then we're able to move forward. Secure connections, that's the one that I will be getting access to. If I want to, for example, open it in Notepad or something, let's do it. Open with, could we do this? Oh, even this one, yeah. Will I be able to get access to this file? No, that's the point. That's the good point here. Yes, it just doesn't open. Yes, but effectively, if we put it into this one in the Notepad, the same. We will not be able to get access to the passwords. And as you see, yes, we've got information that there are custom passwords failed to decrypt. Of course, because this is not the Freddy's data protection API. Okay. So what about we actually do something about that? Sure. So we're going to use this, and we're going to use master. I'm going to put my master key over here. And here I will specify file and secure connections in C analysis, of course, C analysis and secure connections. Yeah, that's the one. So I'm getting access to all the passwords that were stored over there because they rely on the classic data protection API that is out there. Yes. So this is the setup. Is it difficult to write tools like that? No, yes. To be able to move to the stage where we actually understand how it internally works, it took us over 6 months. So it's a kind of a long period. Maybe we're just lazy. Maybe we're not smart enough, but it was a lot of data to be analyzed. But long story short, our security is as safe as data that we've got within our passwords, or eventually as safe as our domain admin is at the end. Last thing to show you, yes, and then we move forward. Basically, when we are thinking about security, and what about stuff within the different solutions in Windows, yes? Well, basically, in IIS is a very cool thing, because within the IIS, so the web server, which is, to be sincere, one of my favorite things to play with within Windows, that is, everything is relying, really, on the machine keys. And the machine keys are also encrypted by the local security subsystem, so the local system data. Now, in order to show you this, I need to go into the web server, and I need to be in a very cool place, which is a folder where we are storing the .NET Framework settings for the server. So this is the setup, and effectively, what I will need to do in order to get access to the IIS secret data, here we go, is to extract them from the server itself, because they are dependent on the machine security. What am I showing you right now? It's a new feature that was introduced actually in IIS 8, which is called Centralized Certificates. And when we go to Edit Feature Settings, that's the place, by the way, where we store the password to get access to the private key of the certificates. Now, I love these dots. These dots, by the way, they actually represent the password length. Yes. But are they actually stored somewhere in a clear text? No, they are stored in encrypted form, but since we have access to the server, this is not a problem for us. In order to be able to decrypt them, you need to actually extract the private keys of IIS. And we do it by using ASP.NET Red IIS, one of my favorite tools. Administrators quite often forgot, by the way, when they are doing the backup of the web servers, to take them out, because this is the private key that is used to encrypt the IIS use secrets. So, for example, that's also the one that is used within the encryption of the private key passwords in many different places in IIS. So then you will be wondering, oh, I lost my private my PFX password. Well, yes, you will not if you're going to export this file. So I'm exporting this into C test.xml/-pre. So succeeded, good, life is full of success, we can move forward. We've got this, I'm on a C drive, and this is like a little PowerShell script that we have written Of course, it's available on my blog if you would like to have more details about that. But what I'm doing right now, I am loading over here the RSA crypto service provider because it was written by using asymmetric cryptography with the private keys of IIS. But if I have access to private keys, I'm able, of course, to get access to it. What is the cool thing you might get excited about is this line. Because in Windows, you never know from which side you should read, or write, actually, how we are storing data, from left to right or from right to left. And in cryptography, it matters a little bit, yes? So imagine like 20 levels to go through, and each of those, you don't know how this is written, yes? So it's a little bit of a hassle here. This one is quite straightforward. So we have to reverse an array enabled in order to be able to read it. And let me run it. And at the end, of course, what we got is a password. Even though the password is in the registry in an encrypted form, we are able to decrypt it as long as, of course, we get access to that particular password. Yeah? So this is one of the ways how we're able to get access to that machine. Yeah? So this is the case. Simple, right? Very simple. OK. Now, a little bit of a summary. How we are able to trace all of that I was talking about. Well, this is actually quite simple because Procmon, so the one that you can download from sysinternals.com, is the tool that you can use in order to monitor what's happening on the disk. Yes, so different types of disk-related operations. There are a lot of them, but in operating system, there's more reads than writes. You will see we are not writing things very often. But when you are changing the password, and if you want to know where is it, which keys are taken into consideration to encrypt it and store it, Sysmon will tell you. Not the Sysmon, sorry, Procmon. I'm in love with Sysmon. Procmon is, of course, what I mean. And you are able to spot all the different types of write operations. So this presentation was prepared only by using Procmon. Yes, and of course, different tools on the top of that. But it's important to understand which type of cryptography we're using. And that's something that we got over here. Anyway. Hopefully it was interesting. You got a little bit more knowledge about where credentials and how are stored. Yes, 45 minutes. It's a great time to give a nice flavor about where the credentials are stored. If you need more information, obviously, then you need to follow me if you want, of course, on Facebook, either Twitter, or I'm writing the blog, which is secureacademy.com/blog. And this is where and not only me, but the whole team, describes all the different interesting vulnerabilities that are out there. We're trying to be super up-to-date, always being in front with all the security situations, so make sure that you don't miss that part. Thank you so much, guys, and I'm looking forward to see you at the end of the conference, yeah? Thank you.